This video is about increasing, decreasing, and constant functions. So a function is increasing on an interval I if for any x and y in the interval, x less than or equal to y implies that the output associated with x is less than the output associated with y. So think about what that means. Let's say you want to have an interval and you want to say, hey, between, remember an interval would be something like, this would be a closed interval from A to B. So let's say the closed interval from 1 to 3, you had the function increasing. So let's just pick a function that's increasing there. For any two values in that interval, let's pick that value for our x, that value for our y. If x is less than y, what does it mean to be increasing? Well, it means the height at x is lower than the height at y. That's pretty intuitive, but you might not have thought of writing it this way. Well, I didn't bother to write down ahead of time what decreasing means because I'm hoping from this description it makes sense to you. If this word was not increasing, but decreasing, a function f is decreasing on an interval I if for any x and y in the interval, if x is less than y, same picture, what do you want to happen? Well, you want something like this. In other words, f of x has to be greater than f of y. So that's the definition for decreasing. Now, there's one last piece here, of course, constant. How does constant work with this? Well, a function f is constant on an interval I if for any x and y in the interval, doesn't matter which one's bigger or smaller, and of course if it's constant we don't want it greater than or less than, we just want f of x equals f of y. So perhaps we'll clean off these two graphs and we'll say, hey, here's x and y. F of x had better be the same height as f of y. That's what we're looking for a constant function. Now, the way that you use this often is to talk about where on a function graph a function is increasing, decreasing, or constant. Now, here's the catch. If I ask you, where is the tallest building in town? You won't tell me, oh, it's 400 feet tall. It's a question about height, but the answer is where it is. You'll say it's downtown at this street, right? So if I ask you, where is the function increasing? You will tell me the location where it's going up. You won't tell me any y values at all. You won't tell me any height. So where is this function increasing? I'll tell you the horizontal location where it's going up as we move left to right. Here it appears that it's going up from 4 up to -2. And I'll include those endpoints because the endpoints seem to be a part of the graph. Now notice from -2 to -1, it appears to be decreasing. So from -2 to -1, it's decreasing. Oh wait, but -1 is actually higher. If I use -1 as my rightmost point, it wouldn't be decreasing. So I'd better exclude that point. Remember, a parenthesis means everything up to that point, but not that point. Now, what happens from -1 to 1? Well, the function is constant. So again, you probably know it's constant there. The question is just how do you communicate that in the language of math? Now, again, from -1 to 3, the function is decreasing, not including, sorry, +1 to 3. So from +1 to 3, it's decreasing, and then it's increasing from 3 to 4. So there you have it. Those are the intervals of increase, decrease, and the constant intervals on a function graph.